noticed. Nobody's ever pointed this out to me. But it's like I start out every lesson with okay. So as soon as I hit go or whatever, and if I go back and if you watch every one of the lessons that I've recorded so far, they all start with me going, okay. So I'm going to learn a lot about myself. And I don't think I'm going to like everything I learn. So here we go. First off, did anybody try any of the homework? Did you have any questions? I mean, some of them may be like, hey, when we get to this today, but did you have...
said we only had to do one page, right?
Well, eventually you'll have to do it all, but that's probably true. I just said try some of the homework. I don't remember what I said. I honestly don't. Does anybody have any questions on those so far? If you did any of them yet, it's okay if you haven't. You know how this works. You'll have time to turn it in. We can always ask questions later.
Is there going to be an answer guide or something?
Yes. Yes, once I assign the entire assignment, there'll be a whole topic on Google Classroom that says answers, and then you'll be able to click and check your answers. And it won't have the work or anything, but it'll have the answers.
I have a question.
Yes, when? Which one?
Can you do number 3B?
Yes, if I can find it. I think I can. Yes, I can. 3 part B, right? Okay. There we go. Okay. Limit as x approaches 1 of h of x. So, what we have to do is we have to look at it from this side and from this side. Because it doesn't say just the left-hand side or just the right-hand side. So we know that the left and the right have to be the same in order for it to work. So when I approach it from the left, it looks like it's negative 2.33 and then something. And I approach it from the right, it's negative 2.33 and then something. So chances are, these look like they're going to like negative 2.3333333, which is negative 2 1/3. Or if you had negative 2.33, that would be fine as well. It's those weird fractional ones that gives us problems at first. After a while, it's like, oh, okay. What else? Anything else yet? Okay. Calculus.
Wait, so what would E be on 3?
D?
E.
E does not exist. Does that make sense? Okay. And that's because from the left, it's approaching negative infinity, and from the right, positive. Good question. Anything else? All right. Well, let's jump into it. So we have this picture, and you are going to probably go up to this picture. I can't show it all on the same page up here because it's just, I don't have enough room. But you can see the whole thing all at once. So it says below it, using this graph, find the value of each of the following limits. If the limit does not exist, state why. So, I think these are fairly straightforward. Not seeing any weird ones. Okay. So let's look at these. Let's start with A. Limit as x approaches negative 3 from the left-hand side. What do you think, Wynn?
Infinity.
Yes, infinity. Very good. Because let's look at it here. Negative 3, so that's this line. And as I approach it from this way, it's going up forever. So that's why it is infinity. Excellent. Okay, on B, limit as x approaches negative 5 of f of x. What is that one, Brooklyn?
Would it be negative 1?
Okay, let's look.
Or would it be negative 1?
Okay. X approaches negative 5. So where's negative 5? Here's negative 5. Okay. So as I approach negative 5, what am I getting close to on the y?
4.
Yeah, I'm getting close to 4. So even though the actual value is 1, the answer for the limit is 4. Because even though that's not a point, we said it doesn't matter if it's actually a point there or not. It's what is it approaching. It can actually touch it or not. It doesn't matter. Good questions. Excellent. I'm glad that came up. Okay, so that was 4. C. Limit as x approaches negative 1 of f of x. Faith?
From anywhere?
From anywhere, yep.
Negative 1?
Yes. You look here at negative 1, that's the x. And then you approach that from both sides. I'm approaching it from the left, and I'm approaching it from the right. And I see what it is on the y. And on the y, we can see that it's 1. Or negative 1, just kidding. At any point, stop me if you have a question. C, the limit as x approaches 3, negative 3, of f of x, Lilies? That is absolutely right. Oops. As it approaches negative 3, let's see, here's negative 3. X approaches negative 3. Oh, I went to 5. Okay, sorry. Here's negative 3. I was like, that doesn't make sense. Okay, if I approach negative 3 from the right, or from the left, sorry, it's positive infinity. And if I approach it from the right, it's going down, it's negative infinity. So since they're not the same, it does not exist. Good job. And it says, if it does not exist, explain why. So you could just say the limit as x approaches negative 3 from the left is infinity. Yep. And the limit as x approaches negative 3 from the right is negative infinity. And those two are not equal to each other. It's not my prettiest writing, but y'all have been with me before. Okay, so then the limit as x approaches 2 from the left-hand side of f of x. Daniel?
1.
1 is right. So we look at 2. Here's 2. From the left-hand side is coming from this way, and we see that it's 1 on the y-axis. Excellent. Stephen, what about limit as x approaches 2 from the right-hand side?
6.
That is 6. That's coming from the other way. And notice that it's approaching. It's an open hole, but that doesn't matter. It's approaching 6. All right, last 3. Limit as x approaches 2 should be, does not exist. Let's see, as it approaches 2, we see on D and E, they're not the same thing. So, does not exist because D does not equal E. Limit as x approaches negative infinity is 2. Negative infinity. That means as I go to the left forever and ever and ever, I'm getting closer and closer to that asymptote, which is 2. And the limit as x approaches infinity. What's f of x approaching? Infinity. So as I go to the right forever and ever and ever, it's going up forever and ever and ever. That's why it's infinity. Excellent. Okay, last one. I want you to try to do this one, and then we'll just fill in these answers.